So on the second example, when I look at what I have here, in this case, I don't have two variables. I only have one variable, and then I have a whole bunch of constants here. So when I combine these, I have 3x and 6x, and I have 19 and minus 10. And notice how the sign got captured. There's no signs floating around. Everything has some sort of mark under it. So when I combine my x's, I have 3x plus 6x, which is 9x. When I combine my constants, I have 19 minus 10, and 19 minus 10 is positive 9. So when I combine those, I have 9x plus 9. Okay, when you are combining like terms, finding perimeter, nothing is different. So in this first example, I have a square. So if one side measures x, that means all four sides must measure x. So I have x's to represent each one of these sides, x, 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 x. And to find the perimeter, it's x plus x plus x plus x, which is 4x. On your own, go ahead and pause the tape and find the perimeter of this triangle. Okay, because this one's a little trickier, I'm actually going to do some coding on the drawing here. First, I'm going to get all my variables together. So I have an x, and I have a 2x, and then I have a positive 5 and a minus 3. So when I look at my variables, 2x plus 1x plus 1x is 4x. So because I know for sure that there's 4x, I can automatically eliminate C and I can automatically eliminate B. Now this part is a little bit trickier. I'm sure some people might have put A, which is actually incorrect, because what you're really combining is positive 5 minus 3, and 5 minus 3 is positive 2. Okay, next we're going to move on to the distributive property. The distributive property is used to generate equivalent expressions. And basically what the distributive property says is that when you have numbers inside the parentheses and something on the outside, you multiply the outside value by both inside numbers. So in this case, it would be 6 times 2a, which is 12a, and 6 times 6, which is 36. In our second example on the right here, same idea. We have one value on the outside the parentheses and then some values on the inside. So 4 times 8 is 32. 4 times 4n is 16n. But here's the difference between these two examples. In the first example, we had a plus sign in the parentheses. In this example, we have a minus or subtraction sign in the parentheses, and that sign matters. So after we distribute in the first example, we have 12a plus 36. And after we distribute in the second example, we have 32 minus 16n. This is a really basic concept that we covered earlier in the year. Here's a couple trickier ones for you to try. And what you're trying to do is fill in the blank with what's missing. So go ahead and pause it. And when you're ready, you can play the tape again. Okay, the first example in black type, it says 15a minus 12x equals 3 parentheses minus 4x. So we're looking for this missing piece right here. We need to figure out how we got here. The first thing I'm thinking is, okay, well, if I were to do 3 times minus 4, that's where I'd get this minus 12x from. So 3 times what is going to give me 15a, and that has to be 5a. Because when we distribute this out, 3 times 5a is 15a, 3 times minus 4x is minus 12x. As we come to the one in the red, it's the same idea here. So we have some number multiplied by 12x plus 3n is going to give us the left side of our equation. So some number times 12x gives us 48x. Some number times 3n gives us 12n. Well, that has to be 4, because 4 times 12x is 48x. 4 times 3n is 12n. Same idea down here on the blue. 9a minus 18b equals 3. 3 times 3a is 9a. 3 times minus 6b is going to give us minus 18b. And the last one, 3 times 2a is 6a. 3 times 12b is 36b. And these four examples are really the tough ones.